Hi, I'm Nicola Walsh. I'm a teacher here at the Dublin Academy of Education and I'm a chemistry and science teacher. I have a PhD in chemistry and I've been teaching chemistry for quite a few years and I taught in the UK and in Ireland. So today we're going to have a look at some of the calculations that will appear on your exam. So we're going to look at stoichiometry 1. Now, for stoichiometry 1, it's really important that you get moles, molecules and calculating mass perfect. Because if that is in any way shaky, that's going to spell trouble later on when you look at titrations. So it's really important that you get the basics done and done well. So let's have a look at what we're going to cover. So we're going to start off with looking at relative molecular mass. No, I am not insulting your intelligence. I know you know how to do this, but I want it done my way. Okay. Next, we're going to look at percentage by mass and what percentage of a compound is a particular element. Moles, molecules and atoms, and the amount of a substance formed in a particular reaction. Now, this is where the big bucks are. This is where the marks are. However, if we don't cover this, you can't do this. So the first little bit of this is going to be a recap from 5th year, but I want you to be very precise and show everything. Now, I've examined the Leaving Cert chemistry paper at higher level, and it really shows the people that spent the time going through this perfectly because they're the people that get full marks in this question. Your full marks at the end of this question is for the final answer. But if you only give the final answer and don't show the different steps and you make a very small mistake, you've lost 12 marks. So you need to be able to spell it out for your examiner that you know what you are doing and why. Okay. So why are we doing this? Approximately, on average, for the last 20 years, 8% of the chemistry paper at higher level is related to moles and being able to calculate them. Now, this doesn't just mean in here. There's another class that I do later on for stoichiometry where we look at the gas laws, we look at titrations and take it a little bit further and the limiting reagents. So that 8% is not just what's in here. But if this isn't done well, that 8% is not going to be yours in the exam. Now, in 2019, 16.5% of your paper is this. So it's very important that you can do this and that you don't even need to think about what you're doing in the exam. You can just sit down, hash the whole question out, and you're done. Right, so relative molecular mass. Before we get into the whole thing, I'm going to put 2 formulas up on the board. Some of you might not like formula triangles. Fine, you don't need to use them. I find them beneficial. The first one is for calculating moles, just so I have it on the board in front of me. We've got moles, mass, and your RMM. So the whole object of today is to be able to work out moles and mass. In order to do that, we need RMM, so that's where we're going to start from. The other triangle lets us work out molecules. So the number of molecules is the number of moles multiplied by Avogadro. We'll get to that later. Okay, starting with RMM. The relative molecular mass tells me the mass of a compound. So when we look at an example, you're going to need your periodic table, and I have a copy from the log tables here. Now in your exam, they don't print out the periodic table for you. I'm sure you already know this. You're going to find it in your log tables. In your notes, I haven't given you a periodic table, and I also haven't given you a table of the electronegativities either, because I want you to get used to using the log tables to find what you need to find. Now, so in the periodic table, for each element, you have 2 numbers. The small one is the atomic number, which we don't care about at the minute. And the bottom one, the bigger one, that is the mass number. Now, in some periodic tables, in your log tables, atomic is on the top, mass is on the bottom. In some classrooms, they're actually the other way around. It doesn't matter as long as the bigger one is the mass number. Now, we're going to find the relative molecular mass of carbon dioxide. So this is in the notes and it's on page 3. So I'm just going to go through the 2 worked examples and show you how you do it. Do not skip this step in your exam. and I'll show you why when it comes to moles. If you make a very small mistake here, it's the difference between losing 1 mark and losing 3. So show everything. So let's look at carbon dioxide. Carbon in your periodic table has a mass of 12. We look at carbon dioxide, how many of them is there? There's only 1, because there's no number here. It's assumed that there's 1. Hydrogen, ooh, that's not. Go this way. For oxygen, we have 2 of them, and they have a mass of 16. So masses from the periodic table times 2. And to get the relative molecular mass, you just add them together. So you're going to get 44. And your units are grams per mole. Now in your exam, you don't need to show the units for this as you go. However, it's really good practice to get in the habit of doing that, because there's a couple of calculations where you can use your units to figure out what's happening. If you completely forget a calculation, you use your units to figure out how to get to the answer. Next one. Relative molecular mass of magnesium hydroxide. Now these ones are a little bit more difficult, where you've got brackets and a number outside the bracket. That 2 multiplies everything inside the bracket by 2. So there's 2 oxygens and there's 2 hydrogens. And let's look at magnesium. So it has a mass of 24. There's 1 magnesium, because there's a 1 there. Oxygen, there's 2 of them, and its mass is 16, and hydrogen has a mass of 1, and there's 2 of them. Now, when you add those all together, you will get 58 grams per mole. Now, in your exam, actually calculating this doesn't get you any marks yet. You use the RMM to get moles. If this isn't correct and you haven't shown the examiner how you got to the relative molecular mass, you're going to lose marks in moles. So please show this. It's only an extra little step. It'll only take you an extra 10 seconds, but it's well worth it. Next one. Now on page 4 of your notes, I've given quite a few questions for you to practice on. Yes, I know you can calculate RMM. I know you can. However, please practice them. There's a couple of tricky ones in there, particularly towards the bottom, and these have appeared on the exam before. Right, let's have a look at page 6. Percentage by mass. Now, this is something that hasn't appeared on the exam in a while on its own. And it used to come up, it hasn't come up since about 2006, it hasn't come up on its own, but it used to be worth 6 marks. In more recent questions, it's factored into another question. It hasn't appeared on its own in question 4 like it used to. So it's useful to know how to do it, but it's not something that I would labour over too much. That's a nice one. Right, so my worked example from the notes. I'm just going to write out the example on the board. We want the percentage of lithium in lithium oxide. Okay. I want to find out how much lithium by mass is in this. So the first thing I'm going to work out is what mass of that is lithium. So I want the mass of lithium. So if we look at the periodic table, sorry, over here. If we look at the periodic table, lithium has a mass of 7. There are 2 atoms of lithium in that molecule. So we're going to multiply that by 2. So the total mass of lithium in the molecule is 14. Step 2. I need the overall mass of the whole molecule. So I need the RMM. So for lithium, I'm going to put it as 14. Oxygen, I can say is 16 because there's just one of them. And the RMM is going to add those 2 together, which is 30. And step 3 is to find a percentage. You put the mass of lithium over the total mass. So it's 14 over 30 and times it by 100. And then your final answer should be 46.7%. Now, where are the marks in this? You get 3 marks for writing it like this, for having 14 over 30. And the other 3 come from your percentage. So it's really important that you show your workings. It's not necessary to show this bit here. If you're perfectly confident working it out, that's fine. I still would. This is where the marks are. Now, let's talk about a slip. There's something in an exam called a slip, and if you get your paper back and it has that symbol on it, that means you've made a very minor calculation error somewhere, and that will cost you 1 mark. So if here, when I was adding 14 and 16 together, instead, if I had gotten 29, it's the wrong answer, but your examiner can see that you had the right number for lithium, the right number for oxygen, and then it was just a very minor error when you added them together. That's what a slip is. So instead, you would have 29 here. When your examiner comes to look at this, you won't get 6 marks, but you're going to get 5, because that slip will cost you just 1. It's not going to cost you all 3, so please show your workings. It's really important for this. Right, let's do another one. If I wanted the percentage of carbon in carbon dioxide. So again, work out the mass of carbon. So carbon has a mass of 12. There's only 1 carbon in that, so it's just 12. Our relative molecular mass is 12. This is from carbon, this is from oxygen. It's going to give me 44. And then to find out what your percentage of carbon is going to be 12 over 44 times by 100. And what your percentage is. And I'm just going to grab my calculator off camera to do that. So we have 12 divided by 44 times 100. So 27.3. So again, 3 marks and 3 marks. So it's fairly straightforward, and I don't want to spend too much time going into it because it's unlikely to appear on its own, but it's a nice one to know just in case she resurrects it. By she, I mean the chief examiner. Okay. So there's some practice questions on page 12 of your notes. Please have a go with them. The answers are on the next page, on page 9. Now, let's talk about moles. So the bulk of today's class is going to be talking about moles, molecules, atoms, and calculating mass from a reaction. These 2 are important, and it's important that you show your workings. However, the next bit is really important, so you need to have a pen and paper with you as I'm going through this, because my notes are quite detailed, but you need to be following what I'm doing on the board as I'm going through it, and it's just going to make your life so much easier. Now, moles. Typical. Number 3. Now, a mole is just an amount. It is a word that we use in chemistry to describe an amount of a compound. So like with eggs or something else, if you have a pair, you've got 2. If you've got a dozen, you've got 12. A mole tells me how much of a particular substance I have. And it's a really nice one to use. Now, the definition is given in your notes on page 10, so it's just the amount of a substance that contains 6.02 by 10 to the 23 particles. No, you don't need to remember that number, it's given in the log tables. And that's Avogadro's number. Okay. In your log tables, there's a page where it gives you useful formulas or useful constants. That's where you'll find that number. So get familiar with your log tables, and you don't need to remember what that is. It's handy if you do, but you don't need it. Okay. Now, we're going to use this triangle here. So if I want to work out moles, it's the mass divided by the RMM. So example. I want to find out how many moles there are in 1.5 grams of methane, which is CH4. Now I'm doing question 1 on page 11. The work example is on the previous page, but I prefer doing this one here. Now, you're asked to work out the number of moles. Now, as a chemist, I know moles relates to molecules or particles. So if I know moles, it gives me a rough idea of how much methane there is. So, to work out my moles, it's the mass of whatever I'm trying to find out over the RMM. Now the mass has been given to me in the question, it's 1.5 grams. The RMM of methane, so now this is what we worked out at the start. So we have carbon, there's one of them, so it's just 12. Plus hydrogen, there's 4 of them, and it has a mass of 1. 1.5 over 16. Now, you don't need to put your units in here when you're calculating it. However, it's a good thing to have in there, because if your mass is not in grams, this is a nice reminder, oh sugar, it should be in grams. So just have a double check there. And then your final answer is going to work out as 0.09. And that's how many moles of methane I have in 1.5 grams of it. Now, another one. Let's look at number 2 on page 11. It has 11 grams of hydrogen peroxide. So this is a hair bleach. So again, moles. Your moles is the mass divided by the relative molecular mass. So again, mass is given in the question. And then the RMM of hydrogen peroxide, so there's mass of hydrogen is 1, and there's 2 of them. Oxygen, mass of oxygen is 16, and there's 2 of them. So it will be 11 grams over, so 32, 34. And then when you divide it, it's 0.03 moles. Now, I know this is probably going a little bit slowly at the start, but you need to get your head around this and figuring out that if I want to work out moles in a question, you need to know the mass and you need to know the RMM. So it's really good practice just to kind of find your feet with moles. Now, I'm not going to lie, a lot of people find moles quite difficult, and to be honest, I was one of them. So when I was in school, I found moles, just couldn't do them. Hated them, could not get my head around them. But in my notes, I've put out some really nice steps to help you to get through them, and everyone that I've taught in the last few years has found these really, really helpful. So yes, they can be quite difficult, but that doesn't mean that you can't ace this in your exam. You just need to be careful and methodical now and practice them a lot. And if you do that, you're going to walk away with most of the marks in your question. Right, let's have a look. So on page 12, I put in an exam question. And this came up in 2016. The structure structure of cinnamaldehyde is shown. How many moles of cinnamaldehyde are there in 1.6 grams of the pure compound? Now, cinnamaldehyde is what makes cinnamon smell like cinnamon. Now don't panic if you've never seen this structure before. When you do organic chemistry, you're going to come across this a lot. So if we're working out the relative molecular mass of this, the first thing I will do for something as big as this is to write down the molecular formula. So let's count up the carbons. For carbon, there is 1, 2, 3, 4, 6, 7, 8, 9. There's 9 carbons in that molecule. For hydrogen, there's 1, 2, 3, 4, 5, 6, 7, 8. And then for oxygen, there's just 1. Okay, working out the RMM of this. There's 9 carbons, carbon has a mass of 12. Hydrogen has a mass of 1 and there's 8 of them. Oxygen, there's 1 of them and has a mass of 16. Now, I don't do maths in my head at all, so your total RMM for this is going to be 132 grams per mole. Now, we want to find out how many moles of this. So remember, moles is mass over RMM. Now, in the question, you're told that you have 1.65 grams of your cinnamaldehyde, and we worked out the RMM. So it's 1.65 over 132. So your number of moles is going to work out as 0.0125 moles. Now, depending on where this comes up, this can be 3 or 6 marks. If this comes up in question 4, it's going to be worth 6, so you get 3 for this and 3 for this. They've stopped putting it in question 4, so it's between 3 and 6 marks. It depends every year how many marks it's worth. Right. Now, from here, we're going to now look at molecules and atoms. So there's lots of these to practice in your notes and the answers are given, so please practice them. It's really important that you can do this and really remember moles is mass over RMM. Right, let's have a look at calculating molecules and atoms. We're going to do molecules first. So our triangle that we had was molecules on the top, moles times Avogadro on the bottom. Okay, so anytime you want to work out how many molecules there are in a sample, you take the number of moles of it and you multiply it by Avogadro's constant from the log tables. So, example. Okay, so we're starting on page 13 of your notes. So in the worked example that I've given, there's how many molecules in 32 grams of methane? Okay. Now, to find molecules, I first need moles. Because at the minute, as we look at it, I don't know moles and I don't know molecules. I have 2 unknowns. You can't have that. You need to figure out how many moles are in this. So like how we did before, your first step is to calculate the moles. So it's mass over RMM. So it's 32 grams over so it's 32 grams over 16 grams per mole, which is 2 moles. So that means in 32 grams of methane, I have 2 moles of it. Now, we're going to use moles to find out molecules. So molecules is moles times Avogadro. So moles we worked out is 2. And then Avogadro we get from the log table, so 6.02 by 10 to the power of 23. And that's going to give me, I don't do this in my head, 1.204 by 10 to the 24 molecules. So in 32 grams of methane, that's how many molecules of methane there are. Okay? Now, one thing I will say is, with your calculator, if you have a Casio, which is this one, I'm grey as well, put brackets around Avogadro's number. This calculator for some reason tends to freak out if you do this all in one line. Why, I don't know. Sharps are a little bit easier to use with this, you don't need brackets for that. Okay?